Okay, so this demonstration, okay, that was, of course, Lauren. She had to hear herself. Okay. This demonstration, we're going to take a weak base, a common household item that none of my class members know yet, because I guess I haven't truly been inflicted by the runs, okay? But a household item that you have is milk of magnesia. And milk of magnesia is a fancy word for a precipitate floating in water that doesn't dissolve, made of magnesium hydroxide, right? So if I take some magnesium hydroxide, which we learned is what kind of base?
Weak base.
It's a weak base. Now, why is it a weak base? It doesn't associate very well because magnesium up on the what? Periodic table is very small. Besides that, although it's bigger than other atoms in its what? Row, when it loses 2 electrons, it becomes extremely small. So Mg plus 2 has a high charge density, so it's going to attract the hydroxide ion. But it has a hydroxide. And this is important that you understand. So this is an insoluble compound. Adding some water, there's your milk. It's milk of magnesia, okay? And that's what they call it. It's the milk of that precipitate. It's not. There's nothing special about it. Okay? But that is the milky white substance. Now, people drink that. It doesn't hurt their throat because the MgOH is a precipitate. Therefore, the hydroxide is locked, and it acts as a very, very weak base, barely dissociating. It does have a KSP that we talked about, but it doesn't hurt our throat because there's very, very little hydroxides. But once it hits the stomach, the strong acid can force its hand and make it act as a strong acid, stoichiometrically. Now, careful the stoichiometry here because the hydroxide here, there's 2 of them per 1 magnesium. So let's see, 2 to 1. So if you have hydrochloric acid in our parietal cells of our stomach, a strong acid clearly dissociates, it'll drive and force this to act as a base and dissociate. But you have to be aware there's 2 hydroxides for 1 H+. So how am I going to show that I can actually dissolve a precipitate? And this is one thing you have to understand, is that dissolving precipitates, if the precipitate is a weak base or has a hydroxide or has basic properties, I can take a strong acid and dissolve it. So things can be insoluble, all right? They can be insoluble until I add a strong base. If the negative ion is basic. Now, what negative ions are basic? Well, hydroxide is 1. What's another negative ion that could be basic? Think about the properties of a base. Bases do what? The Bronson-Lowry definition.
H3.
They accept protons. So what bases, what ions can accept protons? How about CO3 negative 2? Carbonate. Can they accept protons? So they're basic as well. So if I've got carbonates, I can add acid to and do what with them? Well, we'll see. Here is a hydroxide that's locked up. By adding a strong acid, what am I going to do? I'm going to force the hand. Hopefully that's enough. I'm going to force the hand of the magnesium. Hopefully I added magnesium hydroxide. And we're getting there. And we should get a clear solution. And as you can see, there's no more precipitate, and you know there's a clear solution because you can see hopefully my finger, well maybe, yeah, there you go. You can see the finger go by. So therefore we have dissolved all of it, and there it goes, a strong acid forced and dissolved. So when you think of things that are precipitates, don't fall in love with the fact they never dissolve. If they have a basic ion, a strong acid can dissolve them. All right, and that's essentially the demonstration Whereas something that was insoluble, but in a strong acid, you made it soluble, as you would in your stomach. Your stomach would force the weak acid to dissolve the magnesium hydroxide, the milk of magnesia, and it would force the magnesium hydroxide to be a base and neutralize the acid, okay, with a 2-to-1 ratio because of the two hydroxides. And of course, taking milk of magnesia is safe for our throat because that precipitate doesn't react with our esophagus or our mouth, but certainly will in your stomach.